parametric form of linear, quadratics, and circles. So usually when we graph, we're used to having a graph of y equals 2x plus 1, something like that, where it's one equation and we have two variables, x and y, and we go ahead and graph it. Now, a parametric equation actually involves having two equations and three variables. So an example of a parametric equation is, or parametric set of equations is, x equals t over 2 and y equals t plus 2. Now here's two equations and three variables, and the reason we might want to have something like this is that usually the third variable could be considered as time, and for one value of time we could actually look at what's happening to x and y independently. And it's relatively simple. So what we want to do here is find the Cartesian equation if we're going to graph it. And all we have to do is make t the subject in one of the equations and sub it into the other one. So let's do that now. So in the first equation with involving x, let's times both sides by 2. We just get 2x equals t. And we can go ahead and sub that into the other equation. So we get y equals 2x plus 2. And you can hopefully see that that's just a straight line. And we can easily sketch this now, where all it's going to be is a straight line going through 2 and minus 2. What about these set of parametric equations? X equals 2t and y equals t squared. Well, if we want to sketch it, we can just make t the subject in one and sub it into the other. So let's make t the subject in this one, so divide both sides by 2, so we get t equals x over 2, and let's go ahead and sub it into this one. So we get y equals t, which we know is x over 2, all squared. We get y equals x squared over 4, or you can think about it as a quarter x squared. And hopefully you recognize that this is a parabola. And it's just going to be something like that. Let's look at one more example. X equals cos theta and y equals sine theta. So this set of parametric equations is a bit trickier because our parameter is theta, and it's kind of difficult to make theta the subject here and then sub it into the other equation. It's going to be a bit of a mess. But we can do something clever with these equations. We can actually square both sides in both equations. So we get x squared equals cos squared theta, and over here we get y squared equals sine squared theta. And the reason we do that is working with sine squared and cos squared theta is a bit easier. And we know if we can add them together, we know it's going to give us 1. So that's exactly what we're going to do. We're going to add the left-hand side of the equations together and the right-hand side of the equations together. So we're going to get on the left, we're going to get x squared plus y squared. And on the right, we're going to get cos squared theta plus sine squared theta. And sine squared theta plus cos squared theta we know is equal to 1. And we've successfully created a Cartesian equation because we've eliminated the third parameter theta. And hopefully you know that that's just an equation of a circle with radius 1 centered at the origin.